Alright guys, so what we're going to be doing when we try and find the formula for a hydrate, it's going to be very, very similar to what we had done before for finding the empirical formula. Alright. However, instead of working just with elements, we are going to be working with compounds, so BaCl2 and water. Remember, because a hydrate is a compound that is bound to water. So I'm just going to write it out, BaCl2, and then you also have water. Okay, not too bad. Now, the hardest part of this, okay, normally we were just given our grams of each element, all right? In this problem, the hardest part is determining how many grams of BaCl2 you have and how many grams of water you have. So what I'm going to do really quickly is I'm going to draw this out for you. So if you can imagine, what you have right now is you have 5 grams of BaCl2 hydrate. Okay, so I'm going to draw that as blue for you to imagine. So you have this compound that's blue, and there are 5 grams of that. All right, and then what happens, what you're going to do to that is you're going to heat it. And what happens to that after it's heated, it's going to have a mass of 4.26 grams. So what that should tell you, okay, is that it originally was 5 grams and included BaCl2 and water. Okay? Once you heated it, okay, it lost mass and became 4.26 grams. So what that's telling you is something is leaving this compound, and what's leaving is actually water. So really nice and easily you can determine the mass of BaCl2 and the mass of water, because the mass of BaCl2 is just what's left over, because that's not being evaporated, that's staying behind. So you have 4.26 grams of BaCl2. Okay. And then the rest of it is going to be water. So what you need to do in your calculator, you're going to take 5 and subtract 4.26. And what I get is 0.74. So that's your mass of water. Not too bad. Just like the chewing of the gum that we did previously in the gumball lab. Alright? Now, just like with empirical formulas, what I now want to do is convert to moles. So I'm going to crisscross swoosh. 1 mole on top. This should get boring at this point. Grams on bottom. Now, I have to calculate my molecular mass of BaCl2. So, my atomic mass of barium is 137.33, plus chlorine is 35.45, but there's 2 of them, so I need to multiply the 35.45 by 2, and I get the molecular mass to be 208.2, or just 208. That's fine either way, guys. Alright, what I would highly recommend is that you practice this and make sure that you're comfortable with doing that calculation. Alright, crisscross swoosh for water, 1 mole. At this point, if you're comfortable, if you already know the molecular mass of water, that's great. If you're not, calculate it. What you'll get is that it's 18 grams. Okay, so here I need to take 4.26 and divide it by 208.2, and I get 0.02 moles. Same thing as with empirical formula still, guys, nothing new. 0.74 divided by 18, what I get here is 0.041 moles. Okay, here is the only place that writing the formula for a hydrate changes. Rather than writing it as a subscript, right? Rather than writing your moles as a subscript like we did before with empirical formulas, right? Remember we did, for example, this would have been C, if this were Ca, then you put your number of moles down here, right? We don't do that right now. Instead, what we're going to do is the following. We write this compound first, all right? And what we can do, we have 2 different choices. You can divide automatically if you want to, or you can write it out front. So I'm going to put 0.02, you put the number of moles out front now. You'll find that where you put the number of moles for this compound never matters, because this is always going to go away. Then, to show that water is bound to this compound, you're going to put this dot right there. And then you're going to put the 0.041 right here. So you're putting them in front like coefficients rather than subscripts. That's the only way that this problem is any different. Okay? Now, same step as with empirical formulas. You're going to divide by 0.02. Oops. Divide by 0.02. And what you end up getting is just BaCl2 with a dot, and then it's 2H2 O, and you're done. That's the entire problem. So the only way that this is different from empirical formula, one, you're dealing with compounds rather than elements, and two, instead of putting the number of moles as subscripts, you're putting them as coefficients. And that's it, guys.